properties of Z transform. Let us get started. Hmm. So what is the first property? Linearity. Just like any other transforms, not most of them, just like Fourier transform or your Laplace maybe, Z transform is also linear. That means constants remain constants, addition remains addition, and yeah, that's that. So that means Z transform satisfies the property of superposition. What happens to the ROC, by the way? So the ROC will be the intersection of the individual ROCs. The total ROC will be intersection of the individual ROCs. Okay, in some of the regions, only the first one X of n will be stable. In some of the cases, only Z transform of Y of n will be stable. Now, whenever you add them to get a collective Z transform, then we should, the ROC, the complete ROC is that region where both of them are stable. Okay, where both of them are stable. Okay. Then second thing, a time reversal. What is this time reversal thing, by the way? What is this time reversal? Time reversal means, now suppose you have a signal x of n is equal to u of n. Okay. Now suppose I have a signal x of n is equal to u of n. Now if at all the n is replaced by minus n, u of n is replaced by u of minus n, then what's going to happen? If u of n is replaced by u of minus n, then you can see the signal is going to be something like this, right? U of n is replaced alpha to the power n into u of n. Now every n is replaced by say minus n. Then what's going to happen is this u of minus n alpha to the power minus n into u of minus n. That's how the signal is going to become, right? That's how the signal is going to turn out to be. In such case, what happens? In such case, what happens is your entire z in your answer, every z shall be replaced by 1 by z. Every ROC border shall be replaced by 1 by the ROC. Okay. That's what the time reversal means. Let us see. Let us just read all these things, and we'll solve problems. Okay, we'll understand. Shift in the time domain. This is similar to your Laplace transform, right? X of t minus t naught was e to the power minus t naught, right? Something like that, into x of s, right? You remember that you had something similar in your z transform. Here also it is same. So shift in the time domain results in multiplication by exponential. In place of z, there you had your what, s, I think, right? E to the power s or something like that. Okay, something similar. Multiplication by an exponential. Okay, your z is replaced by z by alpha itself. Just see the properties. Later we'll try to make some sense out of these while solving problems. Okay. So which are the properties? Z transform is linear. Time reversal results in every z being replaced by 1 by z. If at all there is shift in the time domain, results in a multiplication by z to the power minus n in the frequency domain. Then there is this thing, multiplication by exponential sequence. Okay, it's very trivial, we'll not be using much. Then what else is there? This is a big deal here. This one is a big deal, right? The convolution is converted into multiplication. Okay, this one is a big deal. The convolution, entire convolution being converted into multiplication. Okay, so that you do not have to do that x of k multiplied by h of n minus k, then the summation, right? A normal convolution involves x of k, then h of k, then h of n minus k. Remember, I have told this thing to you earlier also, I guess. And n from minus infinity to plus infinity. Now see here, if at all you have to do this thing, convolution in time, you have done this thing, right? If x of n length is some 20, y of n length is some 30, then you have to perform multiplications. How many? With all the shifted versions, right? Shifted 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, right? If h of n length is something like 20 and x of n length is something like 20, you have to perform around 40 shifts, right? You have to perform. See, this is my x of n. This h of n shall be moved from extreme left to extreme right till the tail leaves, right? So that many number of shifts you have to do, and every time you have to do a array multiplication. Every element shall be multiplied by every other element. Then afterwards you have to add all of them, right? Then you have to add all of them. Such a cumbersome task. Here, when you go for the Z domain, what you have to do is you get an initial trouble. Yeah, you have to take the Z transform x of n, convert it into x of z, and then you have to take Z transform y of n to get y of z. Once you get the transform, what you have to do, you have to perform only one multiplication, right? One array multiplication. Here you see array multiplication with some 40 to 100 replicas or shifted replicas, right? Shifted replicas. Then you have to do summation. Here only multiplication. That's going to reduce a lot of computations there. Okay. So this is also one more very important property, the convolution property of the Z transform. Finally, there is this thing called as differentiation in Z domain. We'll use it while solving problem. Okay. What this means is, if at all you have x of n, if it gets multiplied by n, then its corresponding Z transform is equivalent to its Z transform getting differentiated by factor z, okay, with respect to z, and multiplication by minus z. Okay. So we'll keep this thing in mind. So what are these properties, by the way? What are these properties for, and in what way are they useful? What are these properties for? Now see, the thing is, say if at all you happen to know x of n. Now suppose my x of n is something like alpha to the power n into u of n minus 8. Okay. Say, assume, okay. You already know the z transform of this particular thing. Okay, you already know that. Let me call it as the x of z. Okay, you already know the z transform of this. Now suppose I ask you, what is it, what is the z transform of this thing getting multiplied by n? Okay, then what author is telling is, you do not have to solve the problem all over with the basic formula of z transform. No, no, what you have to do is use the ready result of the z transform of x of n, simply differentiate it with respect to z and multiply by minus z. Okay. That is the idea. Okay, that is the idea, even for all the previous numericals also. Okay, so what are these properties are for? If at all you happen to know, the z transform of, say, alpha to the power n into u of n, say you happen to know, then what will be the z transform of alpha to the power minus n into u of minus n? Okay, so if at all you happen to know the answer of this one, author is telling you do not have to start from the basic formula. Rather, you can use this particular result, do the simple manipulation, and you should be good to go. Okay. That is the idea behind each of these properties. That is the idea behind each of these properties, to make entire computation simple, given that you already know the answer of some previous values. Okay, shall we now try some of them? Yeah, let us try some basic problems. Let us try some basic problems. Okay. So the first problem here is x of n equal to delta n minus n naught. Okay, so first thing here, what author assumes is, you know the z transform of delta n. Do we know? If at all we happen to know the z transform of x of n, if at all we happen to know the z transform of x of n equal to delta n. What is the z transform of delta n, by the way? Z transform of delta n is 1. Are you convinced with this thing, by the way? Z transform of delta n, is it 1? What is the formula for z transform? X of n into z to the power minus n, right? Then the summation. Now x of n is equal to delta n exists only at n equal to 0, right? Delta n exists only at n equal to 0. Okay, that is why no summation needed. X of n in z to the power minus n means 1 into z to the power minus 0. That is only 1. Okay. Okay, so that if delta n is having z transform 1, delta n minus n naught, what should be this z transform? Now let us go back to the property. What is this thing, by the way? It is the same z transform. It is the same question. Only thing is there is shift in the time domain. Okay, if there is shift in the time domain, what shall we do? Here see the previous, let us see the statement here. Let us see the statement here. So if there is a shift in the time domain, this n naught now turns out to be the power of z. Okay, it turns out, that means the x of n minus n naught. What we have to do now? Simply we have to multiply by z to the power minus n naught. Okay, keeping this thing in mind, So what will be the Z transform here? 1 multiplied by Z to the power minus n naught. 1 multiplied by Z to the power minus n naught. Okay, that shall be the Z transform. Any changes in the ROC, by the way, you can say this was 1, right? So the ROC was entire Z plane, right? Nothing can make this thing 0, nor anything can make this thing go to infinity. So ROC was entire Z plane. Whereas here you can see ROC remains same. But if at all I substitute Z equal to 0 here, what's going to happen? 1 by Z to the power 1 by 0. 1 by 0 goes to infinity. So ROC is entire Z plane except Z equal to 0. There are poles, right? There is pole at origin. Okay, there is a pole at origin. Okay, got this thing. That is the ROC of this particular thing. But anyway, we have successfully applied the time shift property. Shift in the time domain, we already knew Z transform. This simply gets multiplied by Z to the power minus n naught. Okay, okay. Yes. Now, the second question here. X of n equal to u of n minus n naught. Now, do we know what is the Z transform u of n here? If at all we know what is the Z transform of u of n, if at all we know what is the Z transform of u of n, then if at all we know Z transform u of n, then u of n minus n naught, u of n minus n naught can be got by, this can be got by simple multiplication, Z to the power minus n naught into this particular Z transform. So do we know what is the Z transform of U of n? This is a standard problem, right? Z transform of U of n. Now that we are in the fourth class, I think, right? Third or fourth class of Z transform, we know Z transform U of n is 1 divided by 1 minus 1 divided by 1 minus Z to the power minus 1. Okay. Or I can also write this thing as Z divided by, this is also written as Z divided by Z minus Z minus 1. Now this thing we already know, right? U of n is that transform. You know, here what we have to do, since there is a shift in the time domain, you simply have to multiply this by Z to the power minus n naught. Okay. So its Z transform becomes so its Z transform becomes what is it? Wait a second, just give me one moment, okay? Just give me one moment. I think I have the slides which I'm looking for are, you know, not here. Okay, just give me one moment. Okay, sorry. Yeah. Which one? No. Yeah. Sorry for that interruption there. Okay. Okay. Now, yeah. I wasted some time. Okay. So see here. Do we know already the Z transform of U of n? See, these are templates you are supposed to know this. Z transform of U of n is Z divided by Z minus 1. Okay. So we know this, right? Alpha to the power n into U of n, the first problem that we solved, right? The first infinite duration. So what is the Z transform of this? The Z transform of this was Z divided by Z minus alpha, right? Remember this, Z divided by Z minus alpha with ROC magnitude Z greater than alpha, right? Remember this. So similarly here, see alpha, what is the value of alpha here? Alpha is 1. So dou Z divided by Z minus 1. Magnitude Z greater than alpha. What is alpha? 1. Okay. If you already happen to know this, then what you have to do here? Simply this thing shall be multiplied by, so here what is it? The U of n minus n1. You simply multiply this by, Z to the power minus n naught. Okay, simply multiply this by Z to the power minus n naught. Okay, that's that. Okay. Now, the third problem. Here what you will do, what has happened here? Here the author assumes that you already know, not assumes that. First we have to compute the Z transform of alpha to the power n into U of n. Now see here, let me tell you, if at all you want to perform the direct substitution here, it is so tricky because see, alpha to the power n into u of n plus 1, you have to do the summation, right, from minus 1 to infinity, right? You have to do the summation from minus 1 to infinity. Then you have to do the substitution, put k equal to n plus 1, then you have to change the limits and so on, right? It's too tricky. Instead, by solving, using the properties, this can be done much more easily. Okay, that's what author is trying to make a point here. Okay, let us see this particular problem now. See, if at all you happen to know the z transform of alpha to the power n into u of n, this as I said, this is the same template I was referring to, z divided z minus alpha. So now n minus n naught, right? So here n naught is minus 1. So that is why my answer will be simply multiply this by factor z to the power plus 1. So here is my answer. Change in the arrows is, by the way, no, arrows it doesn't change, it remains the same, meaning it's still the same. Okay, meaning it's still same. Now here, which property we will use? You can see here, this is not a plus 1 or a minus 1, but n has been multiplied by factor minus 1. So here we have to use the time reversal property. What does the time reversal property say? Shall we go back and see that particular property? The time reversal property here says that if at all you know the z transform of x of n, then the z transform of x of minus n makes every z to be replaced by 1 by z. So in your answer, if at all you know the z transform of x of n, then the z transform, to find z transform of x of minus n, you have to replace the z by 1 by z, and ROC, whatever you have radius r, now it shall be replaced by 1 by r. That means if radius is 1, it should be replaced by 1 by 1. If the radius is 2, it shall be replaced by 1 by 2. Okay. Okay. So we'll see that now. Okay. Yeah. What is that problem? U of n, right? U of minus n, right? Now see here. See here. You already know the z transform of u of n. What is z transform of u of n? Z divided by z minus 1. Okay. So z transform of u of minus n would be, what should we do? Every z shall be replaced by 1 by z. Every z, you can see this z also replaced by z to the power minus 1 or 1 by z, whichever you are comfortable with. And what else has happened, by the way? Now you can see the right-sided sequence u of n has been turned into a left-sided sequence. So that means every ROC shall be the inverse. If at all it was earlier, stable outside the circle and unstable inside the circle, now it will be the complete complement. Earlier it was stable outside the circle, now it is stable inside the circle, because the z was replaced by 1 by z, right? See, in place of z, what we got? 1 by z. Instead of z, we got 1 by z should be less than 1, which straight away meant that magnitude z less than 1 as the new ROC. So whatever that was outside circle now turned into inside the circle. What this thing? Z replaced by 1 by z, and ROC, which was outside the circle, now turned into the ROC inside the circle. Okay, these are first trivial problems. Anyway, do make sense. Here one more thing. This is also time reversal property. Now see here, every n you can see has been replaced by minus n. Every n shall be replaced by minus n, so that you want to use this particular property. Okay, this is also very important. So we know the z transform of alpha to the power n t of n, z divided by z minus alpha. So here what you have to do is, if at all this is z divided by z minus alpha, then u of minus n, every n has been replaced by minus n, every z shall be replaced by 1 by z. Okay, then z, what happens to z, by the way? Now here, this was z, right? So now 1 by z, 1 by z greater than magnitude a. That means what happens? Z turn into 1 by, right? This comes here, this term comes to here, and this is what the new ROC word get, right? For this one, ROC word outside the circle of magnitude a. Here the ROC is inside the circle of magnitude 1 by A. Okay, we'll be usually in a hurry and we'll simply write inside the arrows radius of circle A. That's why we should not get confused here. Okay, inside circle of radius 1 by A. Okay. Now let me ask you one tricky question here. Now suppose I have alpha to the power n u of n minus 2. Now if at all you have alpha to the power n u of n minus 2, here which property will you use? Alpha to the power n u of n minus 2 if it is the question. Okay, so here what you will do, first thing is here u of n minus 2, we never change the u of n. Okay, this is the like an anchor, this is where we make it. So time shift property should be used here. So what we will do is we will make sure that every n is replaced by n minus 2. So a of n minus 2 into u of n minus 2, this will be there. Now, how do we compensate for this minus 2? Let me simply multiply it by u of a of 2. Okay, this is a constant. Okay, this is a constant. So 2 minus 2 is 2. So here now, here for a to the power n into of n, we'll get the z transform. Then we multiply it by z to the power minus 2 for the time shift property. Then afterwards, what we'll do? We'll multiply by time shift property. And then afterwards, we can substitute the value. Okay, that is the intention there. Okay, that is the intention there. Okay, uh, okay, okay. Yeah. So, yeah, I will continue. Okay, I will continue. So you once again, yeah, you got this particular thing. I will see in future we'll get some similar problems here. Okay, we'll get some. Which was the step by the way? Where second step? Where? Anyway, I will just continue. Okay, I will just continue. So let us see. I'm not getting where exactly. Okay, Rohit, sorry. Okay. Hmm. Okay. Enable pencil. Hmm. Yeah. Do you like to? What was it? Hmm. We'll do one thing. Yeah. Okay. So, yeah. So here, see what happened here. You already knew what is the z transform of a to the power n into u of n, right? It was z divided by z minus a. So a to the power minus n into u of n, every n has been replaced by minus n. If that is the case, every n has been, if it is replaced by minus n, this is the question. This is the question. Your n has been replaced by minus n. So your z shall be replaced by 1 by z, every z replaced by 1 by z. That's it. So we simply apply the property. Okay, we simply apply the property. That's it. Okay. Okay. So now, yeah, next one. Very interesting one. This one here. Okay. This one is interesting. What sort of question is this? Here, n into a to the power n into u of n into a to the power n into of n. If at all you want to solve this, we were to, stick to the formula. Then what we have to do is we have to do the summation, right? From 0 to infinity. N into a to the power n into of n. Now, I do not remember the formula for, arithmetic progression with an n in it. So what I will do is rather I will stick to the property. I already happen to know the z transform of a to the power n into of n, which is z divided z minus a. The moment I see an n getting multiplied, it is the time to use the property. Which property it is? The differentiation in z domain. Whenever my time domain gets multiplied by n, my z domain shall be differentiated with respect to z and then shall be multiplied by minus z. Okay, that's what we will do here. So what we'll do, so first we will, this we know. So we'll differentiate this by with respect to z and then we'll multiply by minus z. ROC remains same. Okay, ROC still remains the same. Only thing is my answer is the differentiation, right? Do we know this particular differentiation? Okay. So 1 by z is minus 1 by z square with this z getting multiplied and all. Okay. So there you get the answer. So this is also one more trick here. The moment you see an n, it is time to use differentiation in z domain property. Now what is the thing here by the way? See this question here. what is happening here? This is the question I was talking about earlier. So this is a to the power n minus 1 u of n. You can see u here is only n. I already know the formula for a to the power n into u of n. I do not know the formula for a to the power n minus 1 into u of n. I don't want to get into it. So what I will do is I will convert this question into, this I will convert into a to the power n into u of n only. So how shall I convert by the way? Then what will happen to this n minus 1? Let me multiply it by a to the power minus 1. If at all I multiply this once again by a to the power minus 1, which is a constant, okay. Now a to the power minus 1 into a to the power n is same as a to the power n minus 1, right? Now this I will keep outside. This I will keep outside the bracket. And this entire thing I will use. So my answer, the z transform of this will be, z transform of this will be 1 by a into 1 by a into what is this? Z divided by z minus a. 1 by into z divided by z minus a. Okay. So when this z divided by z minus a gets multiplied by an n, when this gets multiplied by n, I shall simply do the differentiation. Why he has written this thing? So this is wrongly done here. Okay. Here it is. Okay. What I have to do? Multiply by the d by z. So now see here. Now this question has become, n into a to the power n into u of n with an a to the power minus 1. Okay. So the answer for this question, okay, did you get this particular thing? The way I wrote it is, I shall simply multiply it by a to the power minus 1. Let me simply multiply it by a to the power minus 1 so that this term gets cancelled. So now this question becomes, now this question here with the missing minus 1, this is nothing but n into a to the power n only, right? So whose answer would have been this thing only. Now since this constant was outside, so it was into a to the power minus 1. So this term gone, and what we are left with? Z divided by z minus a whole square. Okay. This is a trick question. So the thing is, if at all you want to apply the property or any property for the thing, every n shall be same. See, n. So this one also wanted to make n. So what I did was a to the power minus 1. I took outside the bracket, treated it as a constant. It was a constant anyway. Okay. So this is also very important two questions. Okay. Now we are ready to solve much more, 2 to 3 layered property questions. Okay. Here is one. Here is one question here. What is this? N into sine pi by 2 n into u of n. How shall we do this thing, by the way? How shall we do this thing? I will do this one particular problem. Okay. Later, okay. I just could not, get the scan of this. So here what I have to do is, first we are supposed to know the z transform of sine pi by 2 n into u of n. Okay. So this question I will do tomorrow. This question I will do tomorrow. Okay. Yeah. Now here, this is one more question, right? Contains 2 to 3 layers of questions here. So what is the tricky part here? You can see there is a convolution here. He is asking us the z transform. So what we have to do is, we have to do the z transform of the first one. Z transform of the first one, sorry. Then we have to find the z transform of the second one. Then the convolution turns out to be a simple multiplication. Okay. So that is the convolution property of z transform, right? In z transform, in z domain, the convolution turns out to be multiplication. Okay, that is the intention. So shall we? So here what we will do, you can see now let us concentrate on the first problem here. Now let us solve this particular problem first. Then we will solve this. Then we shall simply multiply the z domain answers. Okay. Now see here, for this thing what we have to do, first we have to find the z transform. Then we will apply the differentiation in z domain property. Okay. So what will be the z transform? See, this minus, we need not be bothered about this minus. It's just a constant accompanied by some value. Alpha to the power n into u of n is z divided by z minus alpha. What is the value of alpha? Minus 1 by 2. Z divided by z minus alpha. That is why there is a plus sign here. Okay, that is why there is a plus sign here. So minus 1 to the power n, minus 1 to the power 1 by 2 to the power n into u of n gives you z term. Z divided by z minus 1 by 2. Magnitude ROC, whether it is plus 1 by 2 to the power n or minus 1 by 2 to the power n. ROC is anyways outside 1 by 2 only. Now that there is an n getting multiplied here, our answer shall be differentiated. Our answer shall be differentiated with the z and then multiplied by minus z. So we will get this particular answer. Okay. So let me tell you one thing. Instead of keeping z divided by z minus alpha form, I always prefer 1 divided by 1 minus alpha z to the power minus 1 form. This I always felt comfortable as a student because 1 by x is minus 1 by x square, right? Differentiation becomes easy. No values in the numerator. Okay. So it depends on your, the kind of comfort zone whichever you are in. Okay. So what did we do here, by the way? So we tackled the first one, right? N getting multiplied. Time to apply the differentiation in that domain property. We applied. We got the answer for the first one. Now let us see second one. How shall we do this particular thing? So here what we will do? You already know. Do we know the z transform of 1 by 4 to the power n into of n? 1 by 4 to the power n into of n is z divided by z divided by z minus 1 by 4, right? That's the formula. Alpha 1 by 4 to the power n into of n. If 1 by 4 to the power n into of n gives you z divided by z minus 1 by 4, 1 by 4 to the power minus n into u of minus n should give you what? Every z shall be replaced by z to the power minus 1 or 1 by z. Every z shall be replaced by 1 by z. So what happens here? Now see. So half 1 by 4 to the power into of n, you got the answer. That's why 1 by 4 to the power minus n. 1 by 4 to the power minus n and u of into u of minus n. It got you every z replaced by 1 by z. Here also, this z also got replaced by 1 by z. That is why your ROC now you can see it became inside the circle. Okay. So now you have your final answer. ROC now has gone inside the circle. Now finally what they will do, the convolution. We got the individual answer, right? One answer is this one and another answer is here in the previous page. Okay, another answer is here in the previous, this answer here. So both of them we will multiply. Both of them will multiply and finally we get our final answer. अच्छा? So we got our final answer here. What happened to the ROC, by the way? What happens to the ROC? You know, this is an interesting question. Here it is quite convincing. The first problem, did you see the first sub question here? Okay. Here you can see the ROC of the first one was outside a circle of radius 1 by 2. ROC of the second one is inside a radius of circle 4. So the complete ROC, first one is stable outside a circle of radius 1 by 2. Okay, outside the circle of radius 1 by 2 here, entire thing, but outside 1 by 2. Second one is stable inside a circle of radius 4. Okay, second one is stable inside a circle of radius 4. So the complete ROC now would be stable in those regions where both the things are stable, which exists for ROC between 1 by 2 and 4. Inside the circle of radius 2, the second system is stable, first one is not. Outside circle of radius